The Bell Boeing V-22 Osprey is an American multi-mission, tilt-rotor military aircraft with both vertical takeoff and landing (VTOL) and short takeoff and landing (STOL) capabilities. It is designed to combine the functionality of a conventional helicopter with the long-range, high-speed cruise performance of a turboprop aircraft. In 1980, the failure of Operation Eagle Claw, during the Iran hostage crisis, underscored that there were military roles for which neither conventional helicopters nor fixed-wing transport aircraft were well suited. The United States Department of Defense, DoD, initiated a program to develop an innovative transport aircraft with long-range, high-speed, vertical takeoff capabilities. The Joint Service Vertical Takeoff/Landing Experimental (JVX) program officially commenced in 1981. A partnership between Bell Helicopter and Boeing Helicopters was awarded a development contract in 1983 for the V-22 tilt-rotor aircraft. The Bell-Boeing team jointly produced the aircraft. The V-22 first flew in 1989 and began flight testing and design alterations. The complexity and difficulties of being the first tilt-rotor for military service led to many years of development. The failure of Operation Eagle Claw, the Iran hostage rescue mission, in 1980 demonstrated to the United States military a need for a new type of aircraft that could not only take off and land vertically, but also could carry combat troops, and do so at speed. The U.S. Department of Defense began the JVX aircraft program in 1981, under U.S. Army leadership. The defining mission of the USMC has been to perform an amphibious landing. The service quickly became interested in the JVX program. Recognizing that a concentrated force was vulnerable to a single nuclear weapon, airborne solutions with good speed and range allowed for rapid dispersal, and their CH-46C Knights were wearing out. Without replacement, the USMC and the Army merging was a lingering threat, akin to President Truman's proposal following World War II. The Office of the Secretary of Defense and Navy Administration opposed the tilt-rotor project, but congressional pressure proved persuasive. The JVX aircraft was designated V-22 Osprey on January 15, 1985. By that March, the first 6 prototypes were being produced, and Boeing Vertol was expanded to handle the workload. Work was split evenly between Bell and Boeing. Bell Helicopter manufactures and integrates the wing, nacelles, rotors, drive system, tail surfaces, and aft ramp, as well as integrates the Rolls-Royce engines and performs final assembly. Boeing Helicopters manufactures and integrates the fuselage, cockpit, avionics, and flight controls. The USMC variant received the MV-22 designation, and the USAF variant received CV-22. This was reversed from normal procedure to prevent USMC Ospreys from having a conflicting CV designation with aircraft carriers. Full-scale development began in 1986. On May 3, 1986, Bell Boeing was awarded a $1.714 billion contract for the V-22 by the U.S. Navy. At this point, all 4 U.S. military services had acquisition plans for the V-22. The first of 6 prototypes first flew on March 19, 1989, in the helicopter mode, and on September 14, 1989 in fixed-wing mode. The third and fourth prototypes successfully completed the first sea trials on USS Wasp in December 1990. The fourth and fifth prototypes crashed in 1991–92. From October 1992, April 1993, the V-22 was redesigned to reduce empty weight, simplify manufacture, and reduce build costs. It was designated V-22B. Flights resumed in June 1993 after safety changes were made to the prototypes. Bell Boeing received a contract for the Engineering Manufacturing Development (EMD) phase in June 1994. The prototypes were also modified to resemble the V-22B standard. At this stage, testing focused on flight envelope expansion, measuring flight loads, and supporting the EMD redesign. Flight testing with the early V-22s continued into 1997. In 2000, there were 2 fatal crashes, killing a total of 23 Marines, and the V-22 was again grounded while the crash's causes were investigated and various parts were redesigned. In June 2005, the V-22 completed its final operational evaluation, including long-range deployments, high-altitude, desert and shipboard operations. Problems previously identified had reportedly been resolved. Development was protracted and controversial, partly because of large cost increases, some of which were caused by a requirement to fold wings and rotors to fit aboard ships. The development budget was first set at $2.5 billion in 1986, increasing to a projected $30 billion in 1988. By 2008, $27 billion had been spent, and another $27.2 billion was required for planned production numbers. Between 2008 and 2011, the V-22's estimated lifetime cost grew by 61%, mostly for maintenance and support. On September 28, 2005, the Pentagon formally approved full-rate production, increasing from 11 V-22s per year to between 24 and 48 per year by 2012. Of the 458 total planned, 360 are for the USMC, 50 for the USAF, and 48 for the Navy at an average cost of $110 million per aircraft, including development costs. The V-22 had an incremental flyaway cost of $67 million per aircraft in 2008. The Navy had hoped to shave about $10 million off that cost via a 5-year production contract in 2013. Each CV-22 cost $73 million in the FY 2014 budget. The Osprey is the world's first production tilt-rotor aircraft, with one 3-bladed prop rotor, turboprop engine, and transmission nacelle mounted on each wingtip. It is classified as a powered lift aircraft by the Federal Aviation Administration. For takeoff and landing, it typically operates as a helicopter with the nacelles vertical and rotors horizontal. Once airborne, the nacelles rotate forward 90 degrees in as little as 12 seconds for horizontal flight, converting the V-22 to a more fuel-efficient, higher speed turboprop aircraft. STOL rolling takeoff and landing capability is achieved by having the nacelles tilted forward up to 45 degrees. Other orientations are possible. Pilots describe the V-22 in airplane mode as comparable to the C-130 in feel and speed. It has a ferry range of over 2,100 nmi. Its operational range is 1,100 nmi. The V-22's two Rolls-Royce AE1107C engines are connected by drive shafts to a common central gearbox, so that one engine can power both prop rotors if an engine failure occurs. Either engine can power both prop rotors through the wing drive shaft. However, the V-22 is generally not capable of hovering on one engine. If a prop rotor gearbox fails, that prop rotor cannot be feathered, and both engines must be stopped before an emergency landing. The auto-rotation characteristics are poor because of the rotor's low inertia. The V-22 can be armed with one 7.62 x 51 mm NATO, .308 in caliber, M240 machine gun, or .50 in caliber 12.7 mm, M2 machine gun on the rear loading ramp. A 12.7 mm, .50 in GAU-19 3-barrel Gatling gun mounted below the nose was studied. BAE Systems developed a belly-mounted, remotely operated gun turret system, the Interim Defense Weapons System, IDWS. It is remotely operated by a gunner. Targets are acquired via a separate pod using color television and forward-looking infrared imagery. The IDWS was installed on half of the V-22s deployed to Afghanistan in 2009. It found limited use because of its 800 pounds 360 kilograms weight and restrictive rules of engagement. Since March 2000, VMMT-204 has conducted training for the type. In December 2005, Lieutenant General James Amos, commander of 2 Marine Expeditionary Force, accepted delivery of the first batch of MV-22s. The unit reactivated in March 2006 as the first MV-22 Squadron, redesignated as VMM-263. In 2007, HMM-266 became Marine Medium Tilt Rotor Squadron 266, VMM-266, and reached initial operational capability. It started replacing the CH-46C Knight in 2007, the CH-46 was retired. April 13, 2007, the USMC announced the first V-22 combat deployment at Al-Assad Air Base, Iraq. Thank you for watching. Information taken from Wikipedia. Link is in the description.